Hey everybody, welcome to another exciting Java class. Today we're going to cover chapter 24, Java for Programmers, on reflection. And reflection is a broad toolkit that's capable of enabling us to get information about classes. The basic idea is that there is a class that has a very unfortunate name. It's called class. So we're going to get information about the class. That's the capital C class. And the class has many methods. I have a special helper class for the class called reflectUtil, which gives us a whole bunch of static methods that enable us to get information about a class. So for example, here we have a fully qualified class name called java.util.date, and what we can do is we can pass the name java.util.date over to a let's see if we can do this. There, java.util.date can be passed over into an argument to class.forName, and that will give us a mechanism that makes reference to precompiled bytecodes that are available in the class loader. So it has to be in the class path, it has to be loadable, it does not work with source. And what you can do is you can discover all sorts of things about the class based only on that string and its ability to get the class instance that corresponds to the class for that string. You'll be able to get superclasses, its interfaces, all the methods, the fields, parameters for each method needed for invocation. You'll be able to do the invocation. You'll be able to get the visibility modifiers. You'll be able to get the data types of the method returns. You'll be able to get the data types of all the fields. In other words, you'll be able to query all the information you need about the class, and you'll be able to execute the methods in the class. And you'll even be able to make new instances of the class. One of the things you'll want to get from the instance is information about properties in the class, and these things are obtained through the so-called accessors. And so when you get something, for example, get name, if you determine if something is true, like is the customer a deadbeat, you'll be able to use the accessors in order to be able to get information. So then the question is, well, how can you use these accessors to get information about such things as the customer class using reflection? And the answer is, well, you can use reflectUtil in order to be able to do that. Mutators allow us to change properties within an instance of a class. So a method that starts with set, such as set visibility to true, that's typically used for showing a component on the screen. So when you make a new instance of reflectUtil and you pass into its argument an instance of some class you're interested in, you can use reflectUtil to get all the write method names, and so that'll give you the setters. You can get the read method names, that'll get you the getters and the is methods. So if you want to convert a string into a method, what you need is a class C, and you'll be able to call getMethod and pass in the string, and then you'll be able to make a new class associated with invocation, and that will return a method M. Then what you can do, for example, here we'll do get the main method main from a new class, and then you'll be able to do the invocation on the main method. So then the question becomes, well, okay, how do I invoke a method from a string? So we'll be given a static method M, and the first argument to invoke can be null. So M might be main. Maybe what we'll do is we'll invoke it with null as an argument, and we could pass in args if you like. And you could have a static method that takes no arguments. So for example, you could call m.invoke null null and just pass in nothing. The class has to be loadable. You've got to have access to the bytecodes. It's already been compiled. Source code will not be consulted. Source code is not used for this. It's bytecode only inspection. And when you do a class for name, if the name can't be found or loaded because the byte codes aren't there, or because the class loader just can't find it because it's not in the class path, you'll get a class not found exception at runtime. So it relies upon dynamically loading bytecodes with a class loader. If you want to use reflection through the reflect util, just make a new instance of the class, pass it to reflect util, and then you can use method lists in order to be able to store all the methods and get information about the methods. Moreover, when you go and get an instance of an object, you can just call getClass, and that'll get the class instance, and that is supported for all java.lang.objects. So here's an example where we're going and getting a date with a java.util.date, and then we're going to get the class by calling date.getClass. Then we'll go and we'll make a new instance of a thing called a method list. That's my own method. It's a helper method, and it'll give us a list of all the methods contained in the class, and also mechanisms to segregate and subdivide the list. So you can get the write methods for the method list, you can get the read methods for the method list, and that forms two lists. These method lists are mutators and accessors. Read methods are accessors, write methods are mutators. So now you can take the mutations and write, here comes the mutations, and print out the mutators, and then here comes the accessors, and then print out the accessors. So let's see if we can find a way to get a demo on that. What we'll do here is we'll run a little reflection test, and what we'll do is we'll get the class, we'll get the canonical name, we'll print the methods, we'll print the canonical name, and we'll use reflection to actually print information about the reflection test. So let's give that a try. And so here we are. First thing we're going to do here is we're going to get all the methods, and so now it's got a bunch of methods here. Hi, here's a wait method, an equals method, toString method, hashcode method, a getClass method, notify all method, and properties. Davina, I is 10, and here it is. There's I, and here's Davina is 10, and the print method in here, print reflection, well, what it does is it goes through the reflect util, gets the method list, starts with the read methods, and then for each one of the read methods it does an invoke. And what it does is it calls the array of object which has got null in it, and then throws in a value in order to be able to get information, and then it returns an instance of a class which presumably represents the property that the read method returns. And what we'll do is we'll get the display name of the read method using reflect util, and what that does is it removes the set and the is and the get, and then creates a substring which allows us to get a proper name. So if it says set visible, it'll just return visible. And what we'll do now is proceed to do a print of the object. So when we deal with the reflection test in this manner, what we're really doing is writing general purpose mechanisms for getting all the properties and printing them out without actually knowing what properties are there. So presumably if I add one property to the reflection test, let's try and add one. Let's try this. Integer j equals 100. Now let's print it. Now he says I is 10. He didn't print out j, but if we set oh, we don't have a getter. So there, the property is there, but without a getter, it won't invoke. And there it is, j equals 200. In fact, it'll probably print j equals 100 if we remove the setter. And sure enough, it does. So that seems to work reasonably well. So now that we know something about how to get information about the class, it'd be really good if we could establish what are called semantics for the class. In order to do that, we're going to use a thing called annotation. And so what annotation does is it enables semantics to be included. So it's not enough that you say that integer I is an integer. You'd like to know what the range is on the integer. Now you could do that with a number model for sure, but you'd like to be able to do it with some sort of annotation that enables you to build graphic user interfaces automatically. And that's very interesting. So what we'd like to do is have some mechanism for introducing semantics for Java. And so Java, generally speaking, lacks these semantics. They lack the usage. So if you said, well, I've got a double x, how do you know what the double should be? What's the range on x? Could it be 0? Could it be negative? How can I know these things, and how do I tell Java what the range is on x? And similarly for Boolean elements, I'd like to know the default value. I'd like to be able to have a visible name. And so what I do is I establish a runtime retention annotation facility. And this is new, right? We use @retention. And then we proceed to describe at interface what the Boolean range is. It'll get us a value, which can be true or false. It'll give us a name, which will give us some visibility. So Boolean range is something that we can put into the comments in order to be able to establish the semantics for the Boolean usage. So here's a example where Boolean range comes in with a default value of true, and the name is visible. So now if somebody wants to set dumb, that's some extra property, and that can be true or false. And now we can go in and we can do the same thing for colors. We can have a background color, a foreground color, and we'd like these things to be something that we can edit in the future. So what we'll do is we'll establish the colors, and this goes right into the area above the method where comments would normally go. And so what we'll say is, okay, here's a Boolean range, and in the range is true or has true or false in it, and we'll default it to true, and it has the visibility display, which is different from dumb, and then we have some foreground and background colors described in 24-bit quantities. These are hexadecimal quantities. And now we can establish a range for a variety of values. Here we'll do it for doubles. We'll have an increment, a minimum, a maximum, a name, maybe some sort of default value. And then when we want to use it, we'll say @range, and we'll give it the default value, minimum, maximum, perhaps the display name, and then an increment. And all of that will be how we use y. All right, so when somebody says set y, they'll know what the semantics are when they go to automatically construct a graphic user interface. Here's an array of names, and these names are used to describe a series of different variables which go into what we call a range array. Each one of the elements in the array has a value, a minimum, a maximum, and an increment. And so now we can have a whole array of properties. And so here's an example where we have the minimum and maximum in a homogeneous array, but the names are different for each one of the array elements. And so that's kind of interesting because now we can establish the corner points for something like a rectangle. And we recall the spinner number model. Now we can have spinner number properties. They can describe whether the spinner is visible, whether it's compact in its layout, whether the increment is hidden or not. So here are spinner number properties being displayed. Is visible is true. It's not compact. Compact could make it somehow smaller with a different layout manager. The increment is not hidden. And so now we have some number, z, and we can set z using these constraints. Similarly, we can have text annotation. With text annotation, we can have a display name, we can have a default size, all kinds of interesting text properties could be added later. And so here comes an example where we have a display name called row and a default size of 12. And with these text properties, maybe there's a way in which we can use Greek letters to describe row with an actual Greek letter, the row letter. So here's an example with reflection and annotation. And what we're going to do is we're going to use a thing called the paragraph layout, and that's new. The paragraph layout allows us to establish dimensions, and when we go to use the paragraph layout, we'll be able to put in a name and a text field, and then if we want a new line after that, we just say new paragraph. And this should line everything up. So now when we run paragraph layout, we can see things are nicely formatted. Paragraph layout. That's very unique. Quite unusual. So let's try the this so-called run bean panel. And what we're going to do here is in the run bean panel we'll use reflection to get information about some properties, and we'll have a thing called the web start bean. We'll automate the layout, and we'll use the paragraph layout, and we'll use reflection to describe all of the properties. Here, the properties off on the side, and we'll be able to get those properties from the persisted instance that's been made reference to in preferences. And this is an interesting idea because what it's doing is it's giving us buttons, it's giving us text fields, it's giving us passwords, the hidden text, it's giving us web server IP addresses. All these things have been persisted. Now to see how all that stuff is going to work, you got to take a look at the first of all, you want to see what is a web start bean, right? So that's just a what we're calling a key store bean. It's serializable, and it can be serialized out to a preferences instance, and that uses XML, which is something we can have a little lecture on later. And now we can set and get the properties, and it has no graphic user interface at all. Everything gets stored into the preferences root. And so then if you wanted to take a look at the run bean panel, what it's doing is it's getting the class, getting the method lists, getting the right methods, and then it creates a nice titled border, right? So it's using that titled border, and it's describing the class name and using that for the title. So when you run the run bean panel, you can see that security.webstart appears in the border. Moreover, when it calls init, he sets the layout to be new paragraph layout. And then as he gets the right methods, he can proceed to add labeled text fields. And the labeled text fields will come in with a method. First thing he'll want to do is get the property name. Then he's going to get the read method off of the method list. He'll do an invocation of the getter using reflection and then obtain a value. And if it has a file property, it'll add the file field. If it has a password property, it'll add a password field. Otherwise, it adds a run label text field. And using reflection, we can enter in values and have reflection invoke the setters so that those properties can be persisted into the web start bean, which can then be saved out to a file or preferences or wherever you like. So that's kind of an interesting and an advanced way in which we can use reflection to automate the system. Here's a mechanism that has annotation. Somebody's shoe size is now going to be represented with a default value of 9.5. The minimum is 5, the maximum is 15. The name is shoe size, and an increment of 1 size at a time. When we start to run this payroll, we can see there's your shoe size being set. Here's a some silly thing that's been typed called the silly property. Where's the silly property? Yeah, here's the silly property. And presumably there's a getter. And here it is, get silly. So that was used to print reflection about the graphic user interface. And if we wanted to, we could test the graphic user interface generator. And there we go. So now we got the shoe size. We got pi. We have some decimal quantity. We got a background. Now if we hit OK, the information is serialized out to an XML file. In this case, it's just printed out in XML directly onto the console. Slick, right? So we use a thing called print reflection, which will get the value instance and then go in through using reflection, get all the getters, and print out all the values. Then we take this thing called XML utils, get XML string, which will take a serializable instance and convert it into a string with an XML representation, something which we'll describe in another lecture. So that's what I've got for you for today. This all goes into the Run Annotation editor, which assumes that you're using annotation in order to be able to create your interface. So once you have an interface with a minimum and maximum, building an annotation automatically is certainly something you can do. And that's a very exciting prospect, because what it really means is you don't have to worry about building trivial interfaces anymore. They can be constructed for you automatically. Thank you.